Hey guys, in this video we're going to do some practice problems from the IXL section K.4 underneath Algebra 2. This topic is dividing polynomials using long division. And so the cool thing about this process is that it's actually going to happen exactly the same as you would divide or as you would use long division on regular numbers. So the way you could long divide maybe say 2 into the number 6, well, it's going to also work for polynomials, and it actually is going to be a little bit cleaner. Now the downside, it can be pretty tedious. So make sure you bear with us. If you want to see more difficult examples, be sure to skip to the end of the video. I will be doing a lot of examples and they do take a lot of time. So let's go ahead and get started. So the first thing is that we can go ahead and we can use our long division symbol in the same exact way that we do when we do actual long division. So I'm going to go ahead and start by making a long division symbol. So just like this, I create my long division symbol. Now I need to go ahead and put these two things into my long division symbol. This one right here is called my divisor, and that is because it is dividing this number over here, right? It's dividing this thing right here. So our two names for this is going to be the divisor right here, and on the other side over here, this is going to be the dividend. And an easy way to remember it is that the divisor always divides the dividend. If you know anything about stocks, your dividend is the share that you get. It's the big thing that is broken up and then given out to people. So you can think of your dividend as the big pot of stuff, and your divisor is what divides it. So how this works, the thing doing the dividing always goes outside. So our v plus 10 is going to go outside. And then our thing being divided is always going to go inside. Now, this isn't always guaranteed, but at least while we're doing these problems, we're going to notice that our dividend is bigger than our divisor, right? Negative 9v is bigger than v. So that means we want to put it inside so it can get divided. Now, that's not always going to be true, but at least for these examples, we can use that framework to remind ourselves where things go. Okay, so we set up our long division, and now what we're going to do is we're going to look at the greatest term in our divisor, so right here, the v, and we're going to divide it into negative 9v. So we have to ask ourselves, what happens when we divide v with negative 9v? And well, that question is, the answer to it is just going to be, we get negative 9. Now, if that's hard for you to understand, I want you to also think of it this way. What could we multiply v by to get negative 9v? Well, we could multiply v by negative 9 to get negative 9v. So negative 9 becomes our multiple that we keep track of. So we write our multiple up there, and now we take that multiple and use it to multiply our entire dividend and write it right underneath the we use that, I misspoke, we use this to multiply the entire divisor, and then we write it underneath the dividend. Alright, so just like this, we are now going to go ahead and multiply negative 9 by everything right here. So we're going to get negative 9v, and negative 9 times 10 will be negative 90. And you may notice that matches our dividend. And this is an easy problem. It's rather simple, so there's not too much to do. But this is going to match, and you're going to see why that matches on this next upcoming step. So we write this down here, and now just like with long division, we have to go ahead and subtract this. Okay, so we found a multiple that we wrote up top. That was negative 9. And then we multiplied it to our divisor to find out what was being taken out from the dividend. And then, as we see, we're actually taking out everything from our dividend, right? negative 9v minus negative 9v. Well, this could be like a positive 9v, and negative and positive would cancel. Or subtracting two of the same thing always makes it goes away. And negative 90 minus negative 90, well, those are both the same thing too. They go away. And we get 0 as a result of that division. Now, why is that? That's because v plus 10 could evenly divide negative 9v minus 90. Or in other words, if I had negative 9 multiplied by v plus 10, that would simply distribute to become negative 9v minus 90. Right? So it actually makes a lot of sense why negative 9 is the quotient of this. And all we did was we found out what was the biggest number that could multiply to get this under here. We wrote it up there. We then had to multiply that by the number right there. And notice this is very similar to long division. Right? We multiply it by the number outside of our division symbol, and then we go ahead and write it underneath what's being divided, and we subtract it away. So a good thing I like to do or a list of operations I like to keep track of to remind myself when I'm doing this, is I like to remember that I first look to divide. Right? I'm looking to divide my divisor into the whole dividend. I'm looking to multiply the number I just found after dividing back with my divisor, and then I'm looking to subtract. And I'm going to subtract away the thing that I found right there. So maybe that helps, maybe it doesn't. I hope it does help, but that's kind of the process you're going to go through. You're going to divide, you're going to multiply, you're going to subtract. Okay, so let's go ahead, let's put this answer in and move on to bigger and better things. So negative 9 should be our answer. No, not negative q. Negative 9. And it still wants to say q. Negative 9. There we go. And we'll hit submit. And we are correct. That feels great. And notice we're actually getting a lot of points for these problems because they are hard and they do take a while. Okay, so same thing. We're going to go a little bit faster. We're going to set up our division symbol. So we have c minus 3. That's going to go on the outside, and negative 3c plus 9. That will go on the inside. So remember, our question is, what do we need to multiply c by to get to negative 3c? And well, we just need to multiply that by negative 3. So we multiply by negative 3, we record it up top, and then we multiply our divisor by negative 3. So we have negative 3 times c, which is negative 3c. And negative 3 times negative 3, well, that's equal to positive 9. And notice, right, these are kind of easy, and you notice that this actually perfectly lines up. So that way when we subtract it, we're then going to see that everything here is actually just going to cancel. Meaning it evenly divides, we have a remainder of 0, and so evenly dividing this, or dividing negative 3c plus 9 by c minus 3 gives us just 3. And we can also check that if we want. Over here we have negative 3 multiplied by c minus 3. And indeed, that does check out. We see that equals negative 3c plus 9. So we're all good. So my answer is negative 3. Okay, so, oh, nope, they haven't gotten hard yet. So now, well, the hard part about this is now we're going to have remainders. But we actually do the same exact thing that we normally do with remainders. It's just, it's going to look a little weird because we have a polynomial going on. So we are going to set up our long division symbol. We will have m plus 4 on the outside. And, whoops, sorry, 7m plus 20 on the inside. Now we go ahead, we do the same thing as before, so we're going to ask what multiplies m to become 7m. Well, that would have to be 7. 7 times m would be 7m, so 7 times m. I'll record that down there, and 7 times 4 is going to be 28. I then want to go ahead and subtract this, and now you notice not everything's going to work out so nice. Our 7s are going to cancel, and then we're going to have 20 minus 28, and that's equal to negative 8. So our remainder wasn't 0, it was negative 8. So what do we do with this? Well, what we're first going to do is we got our 7 up here, so we're going to write 7 right there. And then we're going to write our remainder, and we have to do it in a kind of special way. We're going to write plus, and then we're going to put the remainder into a fraction with our divisor. Meaning, we're going to have negative 8 on top, that was our remainder, divided by m plus 4. Now, why is that? That's because negative 8 can never evenly be divided by m plus 4, so we have to just leave it as an unfinished fraction, or an uncalculated fraction. That's why we write negative 8 divided by what we were dividing by. Okay, if this feels weird, just give it some time. I promise with practice, it's going to feel a lot more natural. Nice, that worked really well. I'm very impressed with this software. Okay, so we'll submit it, and we are correct. That is nice. Okay, let's go ahead and same deal. So, we might have a remainder, but honestly, it's kind of good. The more remainders you have, the more it becomes not a big deal. But it is always nice not having a remainder. There's just something that feels nice about it. I don't know, having a perfectly finished problem. Okay, so we set this up, and now we're looking to ask ourselves, how many times does h divide negative 8h? Or, what multiplies h to get to negative 8h? And well, that's just going to be negative 8. So negative 8 times h is negative 8h, and negative 8 times 8 is going to be negative 64. We want to go ahead and subtract all of this. Now be careful when you do this because we're dealing with subtraction of negatives. Remember, subtracting a negative does make a positive. So these are the same and they will cancel, right? Minus the same thing, they go to 0. We can even write 0 there if it makes us feel better. And minus a negative 64. So this will be a positive 64, and a positive 64 and a negative 74. Well, that's just going to make negative 10. So negative 10 is my remainder. I cannot continue to divide with this. H cannot divide into negative 10. So that is my remainder. So I'm going to write as my final answer negative 8, because that's what could evenly divide. And then my remainder was plus negative 10, all divided by h plus 8, the original thing I was dividing by. So we'll go ahead and write that. No, I don't want to do that. Let's try it again. Nice. Cool. Alright, are we going to have some harder ones now? Yes, we are. This is good. So, not going to do all the hard ones, but definitely going to spend some good time on them. Alright. So, we're going to set up our division symbol. And it's a little longer, so, give yourself some space. And a plus 9 will go on the outside. And then we will have negative 2a squared minus 18a minus 1. Okay, so same process, just a little bit longer, and you're going to see we're actually going to have to repeat our cycle 2 times to get through this whole division process. So we will do a divided into negative 2a squared. So negative 2a squared divided by a, what does it equal? Well, that's just going to equal negative 2a. Now, if that's confusing for you, think of it this way. What would have to multiply a to make it become negative 2a squared? And well, that's just going to be a negative 2a. So negative 2a times a is equal to negative 2a squared. And then negative 2a times negative 9, well, that would be a negative 18a. Okay, so that's kind of nice. Remember, I'm going to want to take this away. So I subtract this, and these all actually just cancel with each other, leaving a 0 right there. And now, imagine that negative 1 wasn't there. If it wasn't there, I would be done, and I'd have nothing else to do. But alas, the negative 1 is there, and I'm going to go ahead and bring it down. And you notice this is the same with long division, right? When we do it on regular numbers. So we bring down our negative 1, and what is left over now is just the negative 1. So our question is, how many times can a divide negative 1? And well, it actually can't, right? A is a variable, negative 1 is not a variable, it cannot evenly divide it, we cannot divide it a whole number of times. So what we're going to do is we're going to call the quits right there because we can no longer divide. That's how you know when to stop. And we're going to have negative 2a, and then our remainder, same deal as before, is going to be negative 1 divided by a plus 9. Okay, so that should be our answer. Let's go ahead, see if this is correct, see if I did not make a typo. Oh, darn. Nice. Alright, we'll hit submit. Cool. No typos in there. Okay, so same deal. We're setting up our long division. Hopefully, at this point, you should be able to guess where these terms are going and hopefully start doing this process on your own. N squared minus 10n plus 2. And actually what I want to do right now at this video, so if you're one of my students watching, I want to go ahead and do a giveaway. How about we do the first 3 people to come up to me and say teddy bear get 3 Z-Bucks. Yeah, that's what we'll do. So the first 3 people to say teddy bear to me get 3 Z-Bucks. Okay? And the chase is on. You gotta find me and you gotta say it. Alright. So what we're gonna do is the same as before. We're asking how many times does n divide n squared? Or better yet, what multiplied by n equals n squared? And that's just gonna be n. So n times n, equals n squared. That's good. So n times n is n squared, so we can take that away. And don't forget, n minus 10 will be negative 10n. We want to go ahead and take this away. And that's kind of nice, right? We notice that everything's actually going to go away. They all cancel very nicely. And we will then get 0 that comes out of this, and we have to bring down our 2. So our 2 is left over, and now we have the job of dividing n into 2. And can n divide 2 a whole number of times? Well, no, it can't. So this is going to equal n, the number that divided a whole number of times, plus our remainder, which was 2, divided by the original number, n minus 10. Okay, let's go ahead and write that in here. N plus 2 divided by n minus... Oh, crap. I mean, poop. I'm a teacher. We're not allowed to say bad words. Divided by... What? You know, I was really enjoying the software up until now. N plus 2 divided by n minus 10. Okay, cool. We will hit submit. Yes, it is correct. That's nice. All right, so same deal. Now notice, right, as these get more difficult, it's not that they actually get more difficult, it's just that there's more steps to it. So we're going to go ahead, we're going to go about this again. And t plus 2 is dividing, and we have negative 10 t cubed minus 16 t squared. And now, okay, cool, plus 8t. And so now if you're watching this, right, you might be having trouble with this, and so I want to give you this piece of advice because, you know, you may need it to help you. So notice there's typically a constant term, something without a variable, but we don't have that here. So what I like to do is I like to add that in there by just saying plus 0. Now, it's not going to change the problem a whole lot, but it is going to help us out as we go through this, and it'll be a placeholder just to make sure that nothing gets messed up. Alright, so same question as before. T can divide negative 10t cubed how many times? Or what multiplies t to become negative t cubed? And we'll also, we need to multiply by negative 10, and t cubed, to get to there from a t, we would need t squared. Okay, so negative 10t squared multiplied by t is equal to negative 10t cubed, which is good. So negative 10t squared multiplied by 2 is then going to be negative 20t squared. I want to go ahead and subtract these from each other. And notice, right, t squareds, they can subtract from each other. T cubes, they can subtract from each other. These will actually perfectly cancel. That's good. That's kind of what we planned on. And then we will have a negative 16t squared minus 20t squared. So remember, minus a negative is plus, and that is going to give us 4t squared. Okay, now this is an even better example of how you have to bring stuff down. You have to bring down the plus 8t. And if you want to keep that 0 as a placeholder, go ahead and bring it down too. It may not mess you up too much, but it can help keep things organized. Okay, so now we're going to look at this, and we're going to do the same process. So the question is, now this is what we were working with right there. So the question is, so t can evenly go into 4t squared how many times? Or t times what equals 4t squared? So the answer to that is going to be 4t, right? 4t times t is equal to 4t squared. So what do I do with that? I just tack it on up above the long division that I'm doing. I add it on to the solution I was already finding, and as I find more of these things that can divide into it, I just write them up there. So I have 4t, which can now go multiply t, which will give us 4t squared, and notice we're repeating the process. 4t times 2 is going to be 8t, and that's good because as you notice, these are going to completely subtract, giving us 0 as a remainder. If we want to be technical about it, we can bring down the 0, but 0 plus 0, well, we still have no remainder. So that means that we have no remainder, and so our answer is just right there. Let's go ahead and put that in red. Right there. Okay. Alright, so that means negative 10t squared plus 4t should be the answer. Beautiful. And let's go ahead, maybe we'll do two more. They do get longer, they do get harder. I do want to be with you through it, but it gets to a point where you see the pattern, you just need to do it yourself. So we'll keep on going. We'll see how old Mr. Zoyas feels after getting through these problems. Alright, we have s plus 6, and we have negative 5s cubed minus 24s squared plus 36s. Okay, so same deal. We want to go ahead, find out s can divide into negative 5s cubed how many times? Well, it can divide in negative 5s squared amount of times. So negative 5s squared times s is negative 5s cubed, which is good. It's what we wanted. Negative 5s squared times 6 is going to be negative 30s squared. Okay, whoops, not a plus sign, minus sign. We're going to go ahead and take this away. Notice those guys will cancel, and then minus and negative makes it positive, so this will become 6s squared. And we bring down that last term, and we get plus 36s. So the question on the table, what do we have to multiply s by to make it 6s squared? Well, we have to multiply that by plus 6s. So we multiply it by plus 6. Let's go ahead and how do we get rid of this? There we go. So we have to multiply that by 6s. So 6s times s is 6s squared. And then 6s times 6 is 36s. So that's really nice, right? Because we see that this actually evenly divides. We're left with no remainder. And notice I didn't include that constant term here, the plus 0 right there, because it wouldn't have really made a difference. But we're going to see probably in the next couple examples how that can affect it. Alright, so negative 5s squared plus 6s. Beautiful. Oh, this one is... Oh, okay, cool. This is a really good example of what I was just talking about. Alright, so you notice that this one isn't long, but there is a small trick to it. So we're going to have c minus 3 dividing negative c squared, and typically we would just write plus 4. And now you can do this and there's nothing wrong with it, but you need to realize that you have a term missing right in between here. And it's going to be your c term, your linear term. So what we want to go ahead and do to keep us a little bit more organized, now granted you don't have to do this, but I do advise it, is right here we want to write plus 0c. Why do we do that? Well, we have no c terms, and writing plus 0c is going to help keep us organized as we go through these calculations, and you'll see what I mean. So c can divide into negative c squared, negative c times. So negative c times c is negative c squared. And negative c times negative 3 is going to be positive 3c. Now notice, right? Now I actually have a c term to subtract this from. Because before, had I not accounted for that, this would have just said 4 right there. And then it's very likely that you go ahead and you try and do your subtraction, and before you know it, you're taking 4, which isn't a c term, right? It's not a like term with c, you can't combine it, and you're going to accidentally subtract it with 3. So how do you avoid such an easy mistake? Well, you can just work on your spacing, and you can just write plus 0c, and then plus 4. Okay, so we go ahead and we subtract this. These two are going to cancel, that's good. And then minus a positive 3c, well, that will make it a negative 3c. And then we got to bring down that 4. And so now the final question, c minus 3 divides negative 3c plus 4. So c divides negative 3c, negative 3 times. Negative 3 times c is negative 3c. And negative 3 times negative 3 is going to be positive 9. We subtract this. These two will cancel. And 4 minus 9, that's going to be equal to negative 5. And once we get to negative 5, we're going to realize that c cannot divide negative 5, so we are finished with this. And so our final answer will be what we found in the division process plus our remainder of negative 5 divided by c minus 3. That was interesting. Negative c. Cool. And we'll go ahead and submit that. Okay, we will do one more problem. This video is getting long, but I did promise you we would do some hard ones. And this is another good example of a more difficult one. So we'll do this. Really, once you get past this point, they just get more tedious, meaning they get more difficult. This is a very hard section from IXL, and honestly, this kind of reminds me of when I used to do homework back in the day because, you know, the problems weren't easy and it usually took at least an hour to do, you know, a night's worth of homework. But either way, it's going to be good practice for you. And, yeah. And you should definitely do it. You'll benefit from it. All right. Now notice we do have w cubed and we do not have a w squared in between right there in the middle. I intentionally wrote it like this so that way we can see how we can handle maybe forgetting to write that and not get messed up from that. We just have to remember that we can only combine like terms. So same deal, w can go into negative w cubed, negative 2w squared times. Negative 2w squared times w is negative 2w cubed. And negative 2w squared times negative 3 would be plus 6w squared. Now this is the part where you could potentially get messed up, but you need to remember like terms, right? Negative 2w cubed minus negative 2w cubed, those can cancel. They're like terms, they're exactly the same, those can cancel. Now, my 14w and my 6w squared, those are not like terms, so I'm just going to simply have to write negative, just don't forget your minus sign, w squared, and then I'll bring down my plus 14w plus 12. Okay, just like that is how we could not write the space holder and dodge that mistake. So now the same deal, w can go into negative 6w squared, negative 6w times. Negative 6w times w is negative 6w squared. Negative 6w times negative 3 is going to be 18w. We're going to go ahead and subtract these. So we'll see that these two cancel, which is good, right? You notice this pattern happens. And then 14w minus 18w, that would be negative 4w plus 12. Okay? kind of running out of room, but we can do this division one more time because w can divide negative 4w. So w divided by negative 4w, or sorry, the other way around, negative 4w divided by w is going to equal negative 4. So negative 4 times w is negative 4w, and negative 4 times negative 3 is positive 12. And this is good. This is really good because we notice these are actually going to perfectly cancel, right? Boom, boom. So we have no remainder, and then this is our answer right up here. We'll go ahead and call this a video. It's long enough, and we definitely did a good amount of problems to help you out, whoever you are, wherever you might be stuck at. I think this video will help you. Alright, icing on the cake. Oh, I got it wrong! No way! Okay, well hey, I guess let's do another one. Let's figure out where I went wrong. Oh my gosh. I wrote 12, not 21, didn't I? Oh, that's such a booger. Alright, well. Yeah, alright, well, let's go ahead and do another one. So you notice there's all the steps right here. IXL is very good about showing you, everything that happens. That was it. I had negative 4w plus 12, not 21. The typos, they'll get you every time. Okay, let's go ahead. We'll do one more. This is another good one. Kind of complex. Not too complex, but we'll still do it. Alright, so for the record, right, what mistake did I make on that last one? I wrote 12 instead of 21. Small typo. Anyone could make it. If you're making those kinds of mistakes, don't take it personally, don't take it the wrong way. You probably know the material. You just need to be a little careful. And to be fair, I am getting tired. So we have q minus 4, and we have 7q to the 4th minus 27 q to the 3rd minus 16q. Okay, so q can divide q can divide 7q to the 4th, q to the 7q to the 3rd times. So 7q to the 3rd times q will be 7q to the 4th. 7q to the 3rd times negative 4 will be negative 28 q to the 3rd. We're going to go ahead and subtract these. And we see these guys will cancel. That's good. And we have negative 7, negative 27 minus negative 28. So minus negative will be a positive, and this will generate q, and it's actually just 1 q to the power of 3. Right? You could even write the 1 in front if that makes you feel better. But 1 q to the power of 3. Then we're going to go ahead and bring down our negative 16q. Now again, we do have to be careful. Notice there's a jump in powers from q to the 3rd to just a q. So q can divide q to the 3rd, q squared amount of times. So q squared times q is q cubed. And q squared times negative 4 is going to be negative 4 q squared. So I'll go ahead and subtract these, but realize that when I do that, these will cancel, but these are not like terms. They will just make a negative 4 q squared minus 16q. Okay, I'll go ahead and pick my problem up back over here. So my question now is, what can divide negative 4q squared? Negative 4q squared divided by q, what does that equal? It equals negative 4q. Okay, so negative 4q times q is going to be equal to negative 4q squared. So we'll pretend like that was the problem, right? So negative 4q squared, and then negative 4q times negative 4 will equal a positive 16q. Now, let me go ahead and just make sure I'm not making any kind of typo. I don't want to make a mistake on this. Okay. Yep, that looks good. So now be very careful, because it may be tempting to see a negative 16 and a positive 16 and want to cancel those out. But remember, we are subtracting these, and our negative 4q squareds are going to cancel out. But then we will have a negative 16 minus 16, right? Negative 16q minus 16q is going to be negative 32q. So don't be fooled by that. Don't make a careless mistake. That would definitely lead you down the wrong path. So we would get a negative 32q, and oh, this is a hard one. So q can still divide negative 32q, so we would divide it one more time. And so our final number, right, q can divide negative 32q, negative 32 times. So negative 32 times q would be negative 32q, and negative 32 times negative 4 should be, doing some quick mental math, that would be negative 132. I'm sorry, positive 132. Okay, so it looks like this would be our answer, and we would have 132 as our remainder. So what should our answer look like? It should look like our answer should look like 7q cubed plus q squared minus 4q minus 32. Now, because I don't want to get another one wrong, I'm going to go through and double check my work. And as I check it, I'll go ahead and just kind of check it off. So 7q cubed times q, that indeed does equal that. And then 7q cubed times negative 4, that is negative 28. And so now these subtract, this will become positive, and that will become 1q. Okay, I bring down my negative 16, and that's where my negative 16 came from. I'm not crazy. I didn't make a typo. And so then I'm going to do q squared times q is q cubed. So we're good right there. Then q squared times negative 4. Yep, we're all good right there. Now, these did not combine. They are not like terms. And negative 4 makes it a... Oh, man, I totally made a mistake. Right? Minus a negative, what sign is that supposed to make it? It's supposed to make it a positive. So I did have a typo. So this is supposed to be... Wait. Okay, yep. So this is supposed to be positive, and then that would make this a positive. So 4q times q would be a positive 4q squared. And then positive 4q times negative 4 that would make this a negative 16. And so our negative 16s would then cancel, leaving us with 0 as a remainder. Okay, and so don't forget, our answer is going to have a plus right there. It looks all good, and man, I'll tell you what, that's what it means to check your work. It's not easy, I know it, but that is some good work checking. And that is the kind of stuff that will get you good ACT scores, get you good math scores, get you scholarships. Anything you want to do when it comes to mathematics, this will get you better at it. Oh, but there's no 32. Because we stopped right there, that negative 32 wasn't there anymore. One more time. It's hard to write Q's in here. Alright, so just to double check, so to make sure you're with me, that negative 32 was gone because that was a side effect of having the remainder, right? Of not having this go to 0. So now that that's gone to 0, that's not there anymore. Cool. All right, let's submit it. Yeah, there we go. We got it right. All right, that's the end of this video. Definitely a long one, but very much worth it. So have a good night, guys.